NASA has shut down its public feeds during the biggest moment yet for 3i Atlas, and UFO chats are going wild.
At the stroke of midnight on October 1st, 2025, NASA's homepage abruptly went dark. All that remained was a blank white screen and a single, cold line of text due to a lapse in government funding. All public services are temporarily unavailable. Millions of followers were stunned as a universe of information vanished. No more images, no press releases, no social media updates. And the irony was staggering. At that very moment, hundreds of millions of kilometers from Earth, the interstellar object 3i Atlas was just entering its prime observation window from Mars, our one chance to see a piece of another star system up close. On one side, a sky ablaze with cosmic opportunity. On the other, a black screen. Is this just a bureaucratic coincidence, or a secret that no one is allowed to tell? On October 3rd, 2025, the sky around Mars became the greatest stage in the history of astronomical observation. Every lens, from amateur telescopes on Earth to robotic orbiters drifting through the void, pointed toward a strange speck of light 3i Atlas, the third interstellar object humanity had ever recorded. Its closest approach to Mars was 18 million miles. The number sounds immense, but to astronomers, it was the perfect distance, close enough to see its features clearly, yet far enough to rule out any risk of collision. What made the moment even more electrifying was the fleet of spacecraft already in position. It was as if the universe had set the stage to welcome its new guest. First, NASA's Mars Reconnaissance Orbiter, MRO, humanity's eagle eye, with its high-rise camera capable of resolving details just a few meters across on the planet's surface. Next, the European Space Agency's Mars Express, a veteran in service since 2003, still relentlessly gathering data like a seasoned reporter on the Martian front lines. And finally, the ExoMars Trace Gas Orbiter TGO, Europe's sensitive nose, designed to sniff out the faintest whispers of gas in space, as 3i Atlas appeared. All three orbiters were in ideal positions. A once-in-a-century opportunity was unfolding if everything went smoothly. Humanity would get its first complete dataset on an object from beyond our solar system. In the first few hours, preliminary data was downloaded, and it immediately baffled the analysis teams. The estimated size of 3i Atlas was staggering, up to 4.8 kilometers, the scale of a small mountain range. It glowed with a green light but showed no trace of diatomic carbon C2, an impossible characteristic for a typical comet. Instead, its outgassing was rich in carbon dioxide, CO2, and nickel, elements that simply shouldn't be vaporizing in the cold expanse between Mars and Jupiter. And the strangest part of all, its trajectory was almost flawless. Measurements showed it deviated by less than 5 feet per day, a number so small that mission dynamics experts had to double-check their instruments. A comet, actively venting gas, was flying as if it were being piloted. There was no precedent. A wave of excitement swept through the scientific community. Astronomy forums exploded with discussion. Research teams at Harvard, ESA, and JAXA began drafting preliminary reports. Everyone was counting down to the official images from NASA, the photos expected to be the definitive portrait of our third interstellar visitor. But then, just as the world was watching, something strange happened, not on Mars, but back on Earth. NASA's website suddenly crashed. On the blank white screen, a single line of text left millions of followers in stunned silence. Due to a lapse in government funding, all public services are temporarily unavailable. At first, many assumed it was a technical glitch, but when the NASA homepage remained blank for hours, astronomers knew something was wrong. All public data portals were severed. Projects reliant on NASA were instantly frozen. The official reason was perfectly procedural: the US government had shut down due to a budget impasse, forcing some 15,000 NASA employees into a temporary, unpaid furlough. Anyone who follows American science knows that government shutdowns are real, and their impact on communications and data processing is real. But for this to happen at the most critical moment of an interstellar observation, that's what started the whispers. Into that void stepped Simeon Schmuse, an amateur astrophotographer. He began digging through publicly available raw data from other platforms. He downloaded, calibrated, and stacked the images, meticulously reconstructing each frame like an artist with his mosaic. The result, a faint streak of light at the precise predicted coordinates of 3I Atlas in the Martian sky. It wasn't sharp, not beautiful enough for a magazine cover, but it was enough to pose a question when the official channels fall silent. Can the community light its own way to see what we all long to see? From that moment, the story was no longer just about science. It became a test of transparency. On one side were the reasons for governance budgets, procedures, and administration. On the other was the demand for knowledge data that needed to be analyzed and shared while the world was waiting. In online discussions, people brought up Oumuamua. They recalled other times when data was slow to arrive. And they voiced that familiar frustration when information doesn't appear when it's needed most. And then, another question emerged. Like a new streak of light against the sky, was the shutdown an unfortunate accident? Or was it a door slammed shut just before a moment that demanded to be thrown wide open? Whatever the answer, that peculiar silence accidentally dramatized the entire story. As the sound was cut, all eyes turned to the darkened stage where 3I Atlas continued its silent journey, leaving behind a green trail that made everyone wonder, where did that color come from? Now, let's zoom in on our main character 3I Atlas, and you'll see why it has scientists scratching their heads. First, its size. Initial estimates were 1,400 feet, but new data suggests it's over 3 miles long, making it 1,000 times more massive than Oumuamua and Borisov combined. Picture Mount Everest flying through space. Avi Loeb, the Harvard astrophysicist, called this a statistical absurdity. How could we encounter such a giant as only our third interstellar object, when we should have seen dozens of smaller ones first? But size is just the beginning. Its chemical composition is the real shocker. 3I Atlas glows with a brilliant green light, typically caused in comets by the molecule diatomic carbon, C2. Yet, every telescope confirmed there was no C2 instead. It was ejecting enormous amounts of CO2 and very little water vapor, the complete opposite of a familiar dirty snowball comet. And then, the biggest surprise, it was shedding nickel, a heavy metal, into space while still between Mars and Jupiter, where it's far too cold for metal to naturally vaporize. Loeb pointed out that this is strikingly similar to the exhaust from rocket engines, which are often made of nickel-rich alloys and produce CO2 and nickel. Was this a technological signature? Then there's the trajectory. Comets are normally pushed off course by their gas jets, causing non-gravitational acceleration. Borisov was deflected 300 feet every day, but 3I Atlas, it deviated by just 5 feet per day, as stable as if it were under propulsion. Imagine a race car speeding down a highway without a single vibration. It's too perfect to be natural. These features make 3I Atlas not just a rock, but a cosmic riddle, challenging every theory we have. And when connected to the past, the mystery only deepens from today's strange features. Let's travel back to 1977 when a powerful 72-second radio signal burst from the Big Ear Telescope in Ohio. The astronomer Jerry Amon, reviewing the data, circled it in red and wrote, "Wow," in the margin, and a legend was born. It arrived at a frequency of 1420 MHz, the perfect channel for interstellar communication, and came from the constellation Sagittarius. It was 30 times stronger than the background noise, rising and falling as if a fixed source was sweeping past. Despite decades of searching, we've never heard it again. Now, for the shocking coincidence when you trace the trajectory of 3I Atlas backward in time. It points directly to the origin of the WOW signal. In 1977, 3I Atlas was on the edge of our solar system. Could that signal have been a hello from this object, heralding its arrival nearly 50 years later? Imagine a civilization sends a probe, accompanied by a signal that says, "We are coming." This transforms 3I Atlas from an anomaly into a possible messenger, and it makes my heart pound. While it's just a hypothesis, it forces us to reconsider the universe isn't an empty void, but a place full of stories waiting to be told. Science doesn't exist in a vacuum. Budgets, politics, national priorities. They all swirl around our telescopes like invisible gases. In recent years, budget proposals have sometimes made deep cuts to NASA's robotic science divisions, the very missions like MRO, TGO, and Mars Express that form the heart of this work group. Meanwhile, crewed programs, like Artemis, often retain stronger political support. So, when the shutdown hit just as 3i Atlas was passing by, it ignited a feeling that science had lost its voice at a critical opportunity. It might all be a coincidence, but in science communication, timing can be just as important as the data itself. For now, hope shifts to Europe. ESA has confirmed its observations but has yet to release in-depth details, an understandable move, as the data needs to be standardized, calibrated, and cross-referenced. Europe's reach extends even further with JUICE, the spacecraft currently en route to Jupiter, carrying a suite of sensors that could make November 2025 our next rendezvous. During the period when 3i Atlas enters perihelion, its closest approach to the Sun, where it will be hidden from Earth's view, a spacecraft in a favorable geometric position could see what we cannot. That is the power of perspective, going far away to see up close. The rest is a game of purposeful patience. We will enter an observational blind spot as 3i Atlas disappears behind the Sun. Then, in early 2026 it should reappear, provided it is governed purely by gravity. This sets up the ultimate test that science loves: predict, observe, and compare. If it returns on schedule, we'll have strong grounds to label it natural. But strange. If it does something unexpected, reappearing off course or not at all, the debate will change its name from what is it to who is driving it. In the meantime, another lesson has become clear. Open data is the safety net for public trust, whether it's NASA, ESA, or any other agency. Every raw image released on time is a commitment that science belongs to everyone, just as 3i Atlas began to fade from the media spotlight. Another stage lit up academic conference rooms, Zoom seminars, a flood of preprint papers, and essay-length analyses. The instant wows were replaced by debate, peer review, and language cautious down to the clause. The central question, seemingly simple, is this an extremely rare natural phenomenon? Or is it something engineered by an intelligence? Right now, 6 explanations are circulating. Some believe it was all a bureaucratic coincidence, a dry piece of legislation that just happened to eclipse a rare cosmic moment. Others point to interference from solar wind or the Martian atmosphere, enough to distort a signal. Some lean toward the theory that Atlas is an anomalous object, perhaps a metal-rich nucleus, a rare nitrogen iceberg, or even a type of massive rock we've never seen before. Further out is the idea of a secret campaign, with data being withheld behind closed lab doors. And then come the more extraordinary hypotheses: interference from an unknown technology, or even that Atlas is not natural at all, but a camouflaged artificial structure. To counter the flood of speculation, the scientific community has erected a framework of rigorous verification. Every claim must pass a series of key questions. Was the signal confirmed by multiple instruments? Was it recorded by independent spacecraft? Can it be explained by known natural phenomena? And most importantly, is the raw data public for everyone to analyze? Only after clearing these hurdles can an anomaly move from the realm of rumor to scientific fact. To date, all public data shows a smooth, hyperbolic trajectory and familiar cometary behavior. But the door remains open. Not all the data has been decoded. NASA is still behind a legal wall, and many key publications are yet to come. Atlas, therefore, has become more than an astronomical event. It's a mirror reflecting both science and humanity. On one hand, it shows the power of the scientific process: patient, rigorous, and evidence-based. On the other, it exposes our collective thirst for instant answers, where imagination fills the void faster than any data can. A comet may just be a comet, but in the silence, it can become anything: a hidden mystery, a strange technology, or even a message from a distant civilization. And this is where the story needs you, as an observer, Which script do you choose to believe a mundane coincidence or an extraordinary possibility waiting to be proven? Will you side with the patience of science? Or will you let your imagination lead the way? Share your perspective because the answer will not only define how we remember 3i8 less, but also how humanity confronts the great silences of the cosmos.